Welcome to a brief overview of the thermal irradiance feature in ASAP 2025 v1. I'm using a script included in your distribution, thermalirradiance.inr, and it describes a mid-IR camera with a 2-element lens, a chilled detector in a chilled enclosure with a cold stop separating it from all of the warm environment, a sunshade which happens to have 2 bolts protruding through it, and those bolts happen to just intrude on the field of view of the detector at the corners. So those warm bolts will be expected to produce a little bit of excess thermal irradiance at the corners of the detector. And for the quickest possible bottom line for all this analysis, perhaps the graphic here is a good way to describe it. It's a 9x9 map of the thermal irradiance on the detector, and it clearly shows 2 warm areas at the lower corners of the detector. This is out of focus images of the 2 bolts because the lens is focused for distant objects, not for near objects. And if we look at it at slightly higher resolution, by rerunning this example at higher resolution, we see they're still fuzzy, they're just at higher resolution. But we see very clearly a cold center, warm corners here, slightly warm corners on the other 2 corners, but not nearly as warm as where the bolts are. So this is just seeing a little bit of the edge of the lens hood or sunshade, but this is very warm, and that's the bolts. To look at the numeric results, at the end of the thermal irradiance run, we see a thermal irradiance output, which shows some bundles of objects, their irradiance, which is thermal irradiance, the percent of total thermal irradiance, and the geometrical configuration factor for those groups of objects. Let's take a look at what we actually do in the command context to get these results. And a quick way to find that would be to just look for the therm keyword from the top of the script and do a match case find previous, and it will wrap around to the bottom and find the therm keyword. The therm keyword opens the thermal irradiance mode or context where unique thermal irradiance commands are used. Much like there are unique commands in the display command context, therm is another mode where we get a different set of commands. And the commands we have here are wave source, which is for setting up the wavelength of the reverse trace source that is used to determine the thermal irradiance. Bundle is what makes those groups of objects at a higher level name, so we can take all of the surfaces of lens 1 and group them together using the bundle command for lens 2, for the cold shield interior and exterior, and so on, so that they're reported in the thermal irradiance output by those bundles. We can set the temperature of individual objects individually or by wildcard. Emissivity, the same thing. We can set an emissivity if the default emissivity is not appropriate. Band sets the bandwidth sensitivity that we care to observe at the detector. It's the detector's bandwidth usually, but it is what part of the infrared spectrum, the black body spectrum, are we using to determine the thermal irradiance. Table outputs a table to verify all of these results. Sample sets up the sampling, in this case this 9x9 sampling, and SRC is the reverse trace source, which is at the detector location and size, and it defines the number of rays per sample that is used for determining the thermal irradiance. And finally, the go command tells the therm mode to actually start doing the calculation. And what happens at that point is that it cycles through and traces from each zone on the detector and looks at the energy that is passing every object and tracks that in such a way that it can extract the thermal irradiance and the geometric configuration factor. Just to circle back to that table command briefly, this is the output of the table command that is used to just verify our inputs. So it gives us the temperature, emissivity, and waveband assignments that each of the objects uses for its role in the thermal irradiance calculation. And with that, I have a somewhat brief introduction to the thermal irradiance command. Thank you for joining me. I hope you get a chance to use the feature and you find it useful, and I look forward to working with you in the future. Thank you very much.